Okay, YouTube, in this video we're going to continue to explore how we can look at the graph of an equation as being the set of solutions to some equation. So because we're really concerned with what those solutions might be, graphically interpreting them is going to be a little bit more easily done than algebraically interpreting them at times. So one thing that I want to point out here in this video before we start talking about intercepts is just that, considering these 4 points you see over here in this example on the left, and these would be these points -2, 2, -1, 1, 1, -1, and 2, 2 here. What you can see is that they are graphed in all 4 of these graphs that you see down here. But you can see that also any of these graphs would be possible just by knowing those 4 points. So if you remember in our last video, what we did was we just made a table of values. But what I'm suggesting right now is that maybe a table of values only goes so far in helping you to see what these solution graphs might look like. And so what we're going to do is we're going to explore another characteristic of graphs that we refer to as the intercepts of a graph that are very easy to be found. They're easily found and easy to graph and easy to interpret. So let's go ahead and start by defining what we mean by the intercept of a graph. So we'd say that it's often easy to determine the solution points that have 0 as either the x-coordinate or the y-coordinate. That is to say that when you want to, say, make a table of values, these points right here that have x for their y, or sorry, 0 for their x value are really easy to determine what the y value would be just because plugging in 0 is so easily done. So we would say that whenever you have an x value of 0 or a y value of 0, you must be an intercept. And so that being said, let's go ahead and we'll make a little sketch here. We'd say that an x-intercept is where our graph runs into the x-axis here. So let's say, for instance, I had a graph that did this right here. We could see that this graph would have 2 x-intercepts, and the way I would label these right here are simply these. We would say that this is some x value here, but the y value certainly must be a y value of 0. And likewise here, I could say that this has an x value there, but one thing that's for sure about it is if it hits the x-axis, then the y value of that point has to be 0. And likewise, we could see that for any y-intercept where our graph hits the y-axis, we may not be able to say what that y value is, and maybe it's just some general y value, but we can certainly say that the x value on the y-axis has to be 0 for any point on the y-axis. So we would say that any points where our graph hit the x and y axes are referred to as intercepts because they are the points at which our graph intersects or touches those axes. And so we could see that it is possible for a graph to have no intercepts, one intercept, several intercepts, but what I want to do is just kind of take a look at a few of these here. This first graph here, we can see that this has absolutely a y-intercept right there, but it has no x-intercepts, whereas in the next graph here, we have 3 x-intercepts. And one thing I want to say about this is actually that the origin is both an x and a y intercept if graph goes through. So you can fit that on your paper wherever it fits there. My handwriting is rubbish. But basically, if it goes through the origin, then you have both an x and a y-intercept at the origin here. You can see in this other graph that we have over here, it looks kind of like a sideways parabola, but or maybe part of a hyperbola. We have 2 y-intercepts and only 1 x-intercept. And of course, maybe we could think of a circle that never hits the x-axis or the y-axis as having no intercept. So what I want to do is I want to work on finding intercepts of a graph, both graphically, which means just going and looking at the graph, but also algebraically. So take a look at this very first example here. It says find the x-intercepts of the graph y equals x cubed minus 4x. So without making a table, it seems that we already have a graph of this equation right here. And what we want to do is determine what the intercepts would be. So now you might be thinking to yourself, he's crazy because he kind of listed all the intercepts right here. But what I want to do is show you that yes, we can see that these are intercepts graphically. And the way I can tell you that these are x-intercepts is that for every single one of them, the y value is 0 at that point. And likewise, I could see that the origin point here is also a y-intercept because its x value is 0. So in terms of finding intercepts, what we're going to do is we're basically going to do this graphically, yes, but also algebraically by kind of laying out a set of steps here, a couple of steps here, to find the intercepts of a graph. So we'll start with the x-intercept. The x-intercept occurs where our graph hits the x-axis. So this must be true that it has a y value of 0, or it must be true that it has a y value of 0. So in order to find these, substitute 0, y equals 0 into the equation and solve for x. And the neat thing about this, let's see if I can do this here. We can copy and paste maybe. For a y-intercept, oh, so cool, you guys. For a y-intercept, what we're going to do is we're simply just going to reverse this process here and say, well, then anything that has a y-intercept, what we're going to do is we're going to substitute in 0 for our x values and solve for what the y values had to be at that x value of 0. And so for this very first graph that you see here, the one that I said, well, I wanted to kind of find these intercepts graphically and algebraically, what we're going to do here is we're going to list them. We say x-intercepts graphically first, and then we're going to find them algebraically. So with respect to the x-intercepts, we have 3 of them here. We have -2 with the y value of 0, we have 0 with the y value of 0, and we have 2 with a y value of 0. And our y-intercept, we only had one y-intercept, and that was at 0, 0. So with respect to checking these algebraically now, what we're going to do is we're going to take the equation, okay, and to find the x-intercepts, let's go ahead and start with that. We say x-intercepts. Actually, I'm going to start with the y-intercepts. Sorry, sneaky. A little bit easier to find the y-intercept in this case, because what we're going to do is we're going to say, well, then if my equation has y equals x cubed minus 4x, then really the y-intercept would be what we get when we plug in 0 for x. So the funny thing is, in order to find the y-intercept, you plug in 0 for x. And in this case, we get actually 0 cubed, so we get 0, minus 4 times 0, we get 0. So we can see that we've just verified that our only y-intercept occurred at 0, 0. Now, in order to find the x-intercept, I saved this one for now because it's probably been a while since you had to solve by factoring. But what I'm going to show you is that we're going to plug in 0 for y, and we're going to solve for x. Now, in this case, because I can't isolate x, that is, I have x's to the first power, x's to the third power, what we do is we tend to just set everything equal to 0. Check that out. And we're going to solve this by factoring. So in terms of factoring, I notice that these both have a GCF first, and that greatest common factor is x. So I'm going to take out an x, and I'm left with x squared minus 4. And then the other fabulous thing about this expression right here is hopefully you recognize that that is a difference of squares, and a difference of 2 squares actually factors down into these conjugate pairs, x plus 2, x minus 2. So now because I know that, hey, x times x plus 2 times x minus 2 all multiplied out to be 0, then one of these factors has to be equal to 0 here. There's no other way that I can multiply a set of factors to get 0. So what we're going to do is we're going to set each one of those equal to 0. We're going to solve it. Now, the first one here, it's kind of neat. You set that equal to 0, you're done. So we can see that, hey, you know, one of our zeros here, or x-intercepts, is 0 when y equals 0. But also if y equals 0, we'd say then x plus 2 must also be equal to 0 here. And therefore, subtracting 2 from both sides, we get x equals -2. So we can see that -2, 0 is also one of our x-intercepts. And last but not least, if I were to plug in, say, now x minus 2, so I set x minus 2 equal to 0, we would get x equals 2. And so we would get 2 comma 0. So using these same steps, a little bit different this time, I'm not going to just point out the intercepts of this graph here, and we can kind of look at them visually here. But with respect to the intercepts that we're actually visually seeing, it looks like we have an x-intercept here, and we have an x-intercept here, which are these points here, 0, 0, and -5, 0. And a y-intercept, we have a y-intercept of 0, 0 as well. So we've identified these graphically. Now what we want to do is verify them algebraically. So we'll start with our y-intercept. We have an equation here. It's y equals -x squared minus 5x. To find the y-intercept, remember you plug in 0 for x. So we're going to do that certainly here. We're going to put a 0 here and here. And what we get is y equals -0 squared, which is -0, minus 5 times 0, which is 0. In other words, we get 0. So we've certainly verified that 0, comma 0 is our y-intercept here. And with respect to our x-intercepts, remember our x-intercepts, what we're going to do is we're going to take our equation, y equals -x squared minus 5x, and we're going to plug in 0 for y. And so again, because I have x's squared and I have x's to the first, what I'm going to do is I'm going to set this all equal to 0, or I'm going to recognize that it is equal to 0, and I'm going to solve this by factoring. So again, on the right side here, I look for a GCF first. I want to take out a negative and an x, because they both have in common an x, and plus if I take out a negative, then what I have left on the inside here will be an x plus 5, and it kind of takes that negative out of the equation a little bit here. So in terms of, well, what are our factors here? Well, we have either -x equals 0 or x plus 5 equals 0, and because they both multiply out to be 0, then either -x equals 0 or or x plus 5 equals 0. So we're going to solve both of these. In this case, we could just solve both sides, or solve this equation by dividing both sides by a -1. We get x equals 0 here. Let me put an arrow on that. Arrow. But also here, we solve this by subtracting 5 from both sides. We get a -5. So we see here that our x-intercepts are 0 when y is 0, but also -5 when y equals 0 here. And we can certainly see that those were both the intercepts graphically as well. Cheers.